Space isn't cold. That's a lie. This is the coldest known natural place in the universe. It's colder than empty space itself. Now watch the opposite extreme. When stars explode, temperatures reach billions of degrees. Near black holes, space burns hotter than stars, while the black hole itself is almost absolute zero. How is this possible? On Earth, the coldest temperature ever recorded is -89 degrees Celsius. It's a bitter, dangerous cold, but it's nothing compared to the depths of the cosmos. In space, temperatures fall far beyond anything we experience on our planet. The background temperature of the universe, the faint afterglow of the Big Bang, hovers around -270 degrees Celsius. But some places are even colder. The Boomerang Nebula is -272 degrees Celsius, just 1 degree above absolute zero, the theoretical point where all atomic motion stops. This nebula is actively cooling itself. Gas is expanding outward from its dying central star at such a rapid speed that it's causing a cosmic refrigeration effect, making it colder than the surrounding space. At this temperature, atoms barely move. Heat, which is just the energy of motion, almost completely disappears. The universe here is frozen in an almost perfect stillness. But humans, in our relentless quest for knowledge, pushed even further. We created something colder than anything nature has ever made. In laboratories on Earth, using complex arrays of lasers and magnetic fields, scientists have cooled atoms to just billionths of a degree above absolute zero. At these impossibly low temperatures, something extraordinary happens. Matter enters a bizarre and ghostly quantum state, called a Bose-Einstein condensate. The individual atoms lose their identity, and begin to behave like a single, massive superatom, moving and flowing together as one coherent wave. Now, let's journey to the other end of the scale, to the furnaces of the cosmos. The surface of our own Sun, a relatively average star, burns at a scorching 5,500 degrees Celsius. But that's just the surface. If you could travel to its core, you'd encounter temperatures of 15 million degrees, a pressure cooker where hydrogen atoms are violently fused together to create helium, releasing the energy that powers our solar system. But even a star's core is mild compared to a supernova. When massive stars run out of fuel, they collapse under their own gravity, and then explode in one of the most violent events in the universe. For a brief moment, a single supernova can outshine an entire galaxy. The temperatures in these explosions are unimaginable, pushing into the billions of degrees Celsius. The shockwave from such a blast forges heavy elements, like gold and uranium, scattering them across space. Even more extreme are neutron-star collisions. When two of these ultra-dense stellar remnants spiral into each other and merge, they briefly recreate the conditions just moments after the Big Bang, reaching temperatures of trillions of degrees. And this brings us to the universe's greatest contradiction: black holes. The material swirling around a supermassive black hole forms what's called an accretion disk. As gas, dust, and even entire stars are pulled in, friction and gravitational forces heat this material to millions of degrees, making it glow hotter and brighter than any star. Yet, the black hole itself, the singularity at its heart, is predicted by theory to have a temperature infinitesimally close to absolute zero. It is the ultimate paradox, the hottest known environments in the universe, wrapped around the coldest possible objects. An abyss of perfect cold, surrounded by a vortex of unimaginable fire. From frozen nebulae, where atoms stand still to the cosmic fire of colliding stars, and glowing accretion disks, our universe is a place of breathtaking contrasts. It operates on a scale that defies our everyday intuition, a realm of impossible heat and impossible cold existing side by side. The universe exists between impossible extremes.